Welcome to the Minnesota Stormwater Seminar Series. I am John Gulliver, and I will introduce the seminar series and our speaker. This series of seminars is co-sponsored by the Water Resources Center and the St. Anthony Falls Laboratory, both at the University of Minnesota. The funding for this seminar series comes from the Minnesota Stormwater Research Council, and we are very thankful for that funding. Our speaker today is Joel Moore, a professor in the Jess and Mildred Fisher Endowed Chair of Geological Sciences at Towson University in Towson, Maryland. Joel is the coordinator for the Urban Environmental Biogeochemical Laboratory, a college-wide research facility at Towson University. Joel received a BA cum laude in both geology and history from Wheaton College in Wheaton, Illinois, and went on to receive a PhD from the Department of Geosciences at Pennsylvania State University. He subsequently was a postdoctoral research fellow in the Department of Earth and Planetary Sciences at Northwestern University in Evanston, Illinois. Joel has been performing research on elevated chloride concentrations from road salt runoff since 2013, adding a geochemical perspective to the impacts and resulting challenges of chloride in our surface waters. We became aware of Joel's research when he co-authored 2 papers on chloride concentration in the highly rated journal Environmental Science and Technology. He has been providing lectures throughout the East Coast on chlorides and road salt, where I counted 30 invited lectures. We decided it was about time to invite him to the Upper Midwest. Today, Joel will talk about his work on sensing chloride in regional streams, the groundwater contribution to those chloride concentrations, and the mix of ions that affect the aquatic community. So it is my pleasure to welcome Joel Moore.
Great, thank you so much. Thanks to all of you for being here today. I want to talk to you about road salt, de-icing salt. Here's a picture I swiped from one of my USGS colleagues. Looking at salt plows, it appears to be Salt Lake City, Utah, based on the road signs. So, of course, this work has been possible through funding from the U.S. Geological Survey, particularly the Maryland, Delaware, DC Water Science Center, and Maryland Water Resources Research Center. Some of this I'll touch on briefly. It's been funded by NSF through the Urban Critical Zone, and I've worked with a number of agencies around here. So thought I'd start off with a sensor data from a local watershed here in Maryland, a few miles from me, from a couple winters ago, where the specific conductance of the water got up to about 15,000, which is a little less than a third of that of seawater. So I'm going to come back to this again. I'm excited to talk to you about chloride. So figured I'd start with some definitions, so we're on the same page. Why do we de-ice? Of course, for public safety reasons, to reduce accidents, both traffic and pedestrian. And so the question is, how do we assess the impacts of chloride, and how do we adjust our practices and approaches to mitigate the negative effects for drinking water infrastructure and ecology? So the most common de-icing salt in the US, particularly in the Midwest to Northeast, is sodium chloride, NaCl. But calcium chloride and magnesium chloride are used sometimes on, particular bases, like calcium chloride and magnesium chloride are sometimes used by people for their pets. My university uses magnesium chloride for reasons I'm not entirely clear on. Partly it is easier on the plants, the grass next to the sidewalks. And all these have trade-offs of cost. NaCl is the cheapest, which is why people use it, and the effects on terrestrial, particularly plants, versus aquatic organism. But for all these, once they're applied, there's really no way to remove them from the watersheds except via stream flow, or no practical way at this point. And so as I go through, I'll be talking about chloride and often abbreviate that as Cl, and talk about sodium a little bit, and that's Na. In a few cases, I'll talk about conductivity and specific conductance, which is conductivity normalized to 25 degrees Celsius. And in many cases, that's highly correlated with chloride, and particularly once chloride becomes elevated above background levels. And then some relevant guidelines at the national and nearby level. US EPA back in 1988 set a guideline of having a chronic chloride concentration in freshwater systems of 230 milligrams per liter. That would be the average over 4 days. An acute or 1 hour concentration of 860 milligrams per liter. And those aren't supposed to occur more than once in a 3-year period. These are guidelines. A state would have to adopt them to have regulatory heft in a particular locality. And notice data on that 1988, we've learned a lot since then that suggests in many systems, there may be impacts at concentrations lower than that. In Canada, who set their guidelines more recently, their chronic guidelines are 120 milligrams per liter for chloride and 640 for the acute. So one of the things that's connected to road salt is urbanization. And so the US is becoming more urban. We're adding about 1 million additional acres of urban area each year, which is the same as adding LA, Houston, Phoenix each year. And US urban areas have more than quadrupled since 1945. In conjunction with that, as well as changes in societal practice, the amount of salt we've used for de-icing has increased substantially over the last several decades. So we first did de-icing in the late 30s in New Hampshire. About 1960, we started putting more salt on the roads than sodium chloride that naturally came in precipitation. Rose to a plateau about 1970 and stayed there until the early 1990s, and then jumped up to a much higher level and have continued to increase and have been holding relatively steady over the last 5 to 10 years at something like 23 million metric tons per year in the US. And a really nice study on chloride by Steve Corsi, the USGS in Madison and colleagues, they found that it wasn't just that there's more urban area, but salt use has increased 40% faster than the growth in impervious surfaces from 1987 to 2010. So it's both more roads and we're putting more salt on roads, parking lots, etc. Nice study from a couple of years ago, focusing on Minnesota. De-icing salt's not the only source of chloride to streams. In some regions, particularly those with agriculture, there can be other sources. So this is tons per year of chloride entering freshwater systems in Minnesota. So the biggest is certainly road salt or de-icing salts, and about half that amount are fertilizer use and wastewater treatment plant inputs. But of course, those aren't necessarily applied at the same rate everywhere. De-icing salt is focused often in urban areas where fertilizer is spread over a much wider area, so they are likely to have different impacts on streams. And this will vary somewhat in different regions. Fertilizer is less of a source of de-icing salt, say where I live in the mid-Atlantic. So thinking about the rate and how much per square meter is applied is important. So why do we care? What's the big deal for putting down these de-icing salts? Well, it negatively affects water quality. So one of the effects is on aquatic life. One direct effect is that chloride can have toxic effects on particular organisms. And then an indirect effect is that the elevated conductivity or specific inductance can be an ecological stressor for organisms. And the stress to organisms will vary depending on which organisms are being affected or being impacted, and also the background conditions for those organisms. So one of the organisms that seems to be most affected are Ephemeroptera, or what we often call mayflies. And so on the x-axis here have the conductivity, which is correlated with chloride in this case, and on the y-axis have the density of individuals per square meter. You can see two lines there, a blue line and a green line. Both of them decrease as the conductivity or the chloride goes up, but the blue line, which is salt-sensitive communities, which are mayflies coming from streams that have naturally low background chloride, those decline more rapidly than organisms coming from streams that have higher background conductivity. So the context matters. In the mid-Atlantic, where we have sort of old landscapes, many of our streams have naturally low background conductivity, so the organisms might be more affected than in many places in the Midwest, where the background might be higher. And then here is an example of stoneflies, which are not quite as affected. Notice there's a bit of a decline in the green line compared to the blue line. And the main difference there is between the context, and the more salt sensitive communities are somewhat higher than the more tolerant, but there's not much of a decline there. So those are some of the ecological effects. And then invertebrates are at the base of the food chain or food web. And so then any effects on them sort of propagates upward into the food web. Another effect is drinking water. So as chloride increases, it increases the corrosivity of water. One example of that would be Flint, Michigan. So here's a study from Ted Stetson colleagues. He's nearby at a USGS office nearby to you in the Twin Cities. And he and his colleagues looked at the chloride to sulfate mass ratio, the ratio of the concentration of chloride and sulfate in stream systems across the country. And they looked at it first from 1992 to 1993. And they looked at it versus urbanization. So the x-axis shows low urbanization on the left, high urbanization on the right. And that chloride to sulfate mass ratio increased with more urban land cover. And that mass ratio is of interest because it's an indicator of the corrosivity of water with respect to metal pipes and solder. And so as chloride increases, the water becomes more corrosive, showing that water is more corrosive in urban and salted watersheds. And it's becoming more corrosive with time. So they did the same study, or say it looked at the same set of data, same set of sites or similar sites from 2 decades later, from 2010 to 2012, and found that that ratio has increased over the earlier period. Other effects of de-icing salts are that elevated sodium can be problematic for some individuals. The EPA recommendation is that people who are supposed to be on low sodium diets have sodium less than 20 milligrams per liter in their drinking water, or perhaps they shouldn't use tap water if it's higher than that. And a new effect that's starting to emerge, including being studied by one of my colleagues here at Towson, is chloride seems to increase the rate of disinfection byproduct formation in drinking water treatment plants. So disinfection byproducts are carcinogenic compounds that are formed because of the addition of chlorine to drinking water. And so engineers are trying to balance that out to maximize the health effects of chloride, killing off microorganisms, but minimize the formation of carcinogens. And there's good evidence that increasing chloride concentrations can increase the rate of those disinfection byproducts. And then sadly, not relevant for me here in Maryland because there aren't many lakes around me, but for those of you in the beautiful places like the upper Midwest, adding chloride to lakes can affect how they overturn seasonally. And so if you get really saline bottom waters, then you can get permanent stratification of lakes, or you can alter when the lake turns over in fall and in spring. And de-icing salt is one of the big contributors to a problem that's being recognized more and more globally of freshwater salinization. So here's the paper published within the last year or so, mostly from international authors, and they start their paper by saying widespread salinization of freshwater ecosystems poses a major threat to biodiversity functioning and services that they provide. And among their graphs is showing that for studies done in North America, de-icing salt is the most common source of freshwater salinization. Okay, so that's background and why we care. Now let's look at some of the data for conductivity and chloride increases. So as I mentioned, conductivity frequently correlates with chloride. And so I'm going to step through some of the data here. So this is a nice study done by John Olson, looking at conductivity across the United States, and here focused on the Midwest and the East Coast. And so moving from blue to lighter blue to green to orange and red, the conductivity of the water in the streams is increasing. And so these are predicted natural conductivity, so without human effects. And they find that as you move from east to west, the conductivity gets higher, and the two big effects there are climate, less rain often, and maybe a little more evapotranspiration, and then the presence of limestone and carbonate rocks, particularly in the Midwest. So that's what you would expect, higher conductivity in the Midwest than you would on much of the East Coast. And then when you look at what are actually measured, you can see a lot more red points on the right map than you do on the left map. And a lot of the green points have gone away and been replaced by those red or by orange. And so find elevated conductivities across much of the US, on the East Coast along the Boston to Washington, DC corridor, and then in much of the upper Midwest. And so the reasons that they cite for that are de-icing salts, and then also to a lesser extent, agricultural and land use and some groundwater use in the Midwest. And so seeing across the Midwest and Eastern US increases in conductivity. Study that I did with USGS colleagues, we focused on sites on the East Coast that had high frequency data. So places where they were measuring conductivity and we could convert it via regression equations to chloride, where they were measuring those values every 5 to 15 minutes across at least 3 years of time. And so somewhat unsurprisingly, we find that chloride concentrations increase as you move from the Southeast, from Georgia and North Carolina, up to the mid-Atlantic, and then further increase up into New England. So more snow, more use of de-icing salts, you get higher chloride concentrations. And then within each region, the chloride concentrations increase as the amount of impervious cover increases. And so looking at the Southeast, there's a moderate to weak relationship between increase in impervious cover and chloride. There's something there, but not a ton. Then when you move up to the mid-Atlantic, there's a strong correlation between the amount of impervious cover and the chloride concentrations in those streams. And then when you move up to New England, the correlation is about the same, the strength of correlation, and the slope, the amount that chloride concentrations increase per unit of impervious cover increases even more. And so de-icing salts, snow, you get high chloride in streams. So that was data for the last 10 years or so. This has evolved over the course of decades. So this is another study done by Steve Corsi, again in Madison area at the USGS, and colleagues. And they looked at chloride in streams across the country over 2 or 3 decades. And I'm going to show you some example data from northern Wisconsin and from the Milwaukee area. And sorry, my slides seem to have taken a life of their own. So here's data from northern Wisconsin, looking at chloride concentration from 1980 to about 2010. And you can see that concentrations have gone up slightly in the winter, are about the same in the summer, but they're about 10 milligrams per liter. So relatively low from what I'll show you in a minute. So by contrast, looking at a stream that's in the city of Milwaukee, you can see that over a similar period, concentrations were higher in that urban area, 100 up to 400, and concentrations were higher in the winter than in the summer, and they increased over time, particularly starting in the late 90s. And we've seen some similar increases here in the Baltimore area. The difference between these is that have about 0.5% of impervious surface cover in the northern Wisconsin watershed and about 28% in the Milwaukee watershed. And so these are not high frequency data, but looking at long-term data and flow weighting the concentrations and looking at trends through time. We've seen similar patterns with calcium and non-salt ions in a 16-year data set from the Baltimore region. We think salt's driving much of that. And in some studies we've done on the East Coast, seems like chloride concentrations are actually growing fastest in the places that already have high chloride concentration, so the urban sites. Another study, very nice study from the Midwest, is Hillary Dugan and colleagues. Hillary is at the University of Wisconsin, looked at lakes across North America, and used measured concentrations and the factors that drove those landscape factors to predict chloride concentrations across much of North America. It's a fantastic study. And so here are some data that they featured from a lake in Minnesota, and you can see that concentrations are about 100 milligrams per liter, so well above average, and they increased over a 30-year period up to more like 150, maybe started to come down a little bit. But lake concentrations are increasing as well. So of course, if the river concentrations are increasing, and those are feeding into lakes will increase as well. And the most important factor that they found for increases in concentration and elevated concentrations of chloride were development. And they tested a lot of other factors that could drive it. So highly recommend checking out that study. An earlier study that she and colleagues did looked at lakes with at least a couple data points a year over the period 1985 to 2010. And they found increasing chloride when there was more than 1% impervious cover. And so here's just looking at 62 lakes they had data for from Minnesota, and you can see that most of the lines are pointing up, right? Most of the chloride concentrations are going up. And then, of course, if you're seeing elevated chloride and increasing chloride in streams and lakes, then that should indicate that you're going to see it in groundwater as well. So USGS is doing some nice decadal scale studies looking at chloride concentrations in aquifers across the US. And from the 90s to 2000s, they saw about a 20 milligram increase in the places with the bigger arrows. So for example, the Twin Cities and then the Chicago, Milwaukee area, as well as Michigan and New England. And then places with the smaller arrows are 1 to 20 milligrams per liter. And then data not shown here, they saw increases in the range of 10 to 12 milligrams per liter in some of these same watersheds in the upper Midwest. And then these increases in chloride in groundwater have effects for people on drinking water wells. So a study by Piper et al. In New York looked at chloride in groundwater near minor roads in blue on the graph, major roads in orange, and near a salt barn, and the concentrations in groundwater increased. And again, as I mentioned, increasing chloride often means increasing corrosivity. And so on the bottom right is a picture of some drinking water infrastructure that's been corroded by those high chloride waters. And we certainly see that here in Maryland as well. One, I mentioned that chloride and specific conductants are highly correlated, so I just wanted to show that to you real quickly. Here's a graph with chloride on the y-axis and specific conductants on the x-axis for a site here in Maryland, and you can see that chloride and conductivity or specific conductants are correlated with an R-square of 0.98. And so as I mentioned, can use this sort of relationship to convert the specific conductants that USGS, US Geological Survey, measures at a number of sites and convert that specific conductance to chloride. And then we found that these relationships work well at a regional level. So if you have sites that have conductance, specific conductance data, you can still predict chloride even if you don't have chloride data at that particular site. There are some complications. These were mostly for silicate watersheds. Those sites underlain by limestone might have a little bit different relationship, particularly at lower chloride levels. So that was sort of longer term and larger scale results. Now show you sort of zoomed into a year and look at a couple of sites. And so these are some of that high frequency chloride concentration data in the blue line, estimated from those regression relationships. The orange dots represent grab samples. So someone walked out to the stream, collected it, and they brought it back to the lab and measured it for chloride. So notice this is water year 2015, so October of 2014 through September of 2015, and with a y-axis that goes from 0 to 50 milligrams per liter chloride. So this is a watershed in coastal or near coastal Virginia with relatively low impervious cover, about 1%. And you can see that the grab samples in orange and the high frequency data match up well. There's not much variation, it's mostly between 10 and 20 milligrams per year, and there's not any real clear seasonal signal, at least compared to what you'll see in a second. In Maryland, we do see higher winter chloride at sites with only 1% impervious cover, but this is a warmer site near the coast. Looking at a site in Maryland with 13% impervious cover, Again, that blue line is high frequency data collected every 5 to 15 minutes. And you can see much higher concentrations. Notice the y-axis now goes up to 1,500 milligrams per liter rather than 50 like the top graph. And so you can see that for much of the winter, the concentrations are above the EPA chronic exposure limit, which again is 230 milligrams per liter. And if you were relying only on the grab samples, the orange dots, you'd miss much of what was happening in the winter. You wouldn't know how much of the winter that you're above that EPA chronic exposure, and you would not know for sure that you were ever above the acute exposure limit because no grab samples were collected at that point. So if you really want to understand what's going on in watersheds and how the ecology is being affected, then it's important to have high frequency data, at least in the region, that you can use to understand the factors that drive it. And Steve Corsi at the USGS and colleagues saw similar patterns in Milwaukee, Wisconsin. So the winter chloride concentrations based on this high frequency data were about 141 milligrams per liter on average versus 80 milligrams per liter for non-winter. And here I'm defining winter as December to March because that's when most of the salting or nearly all of the salting happens in the mid-Atlantic. Something that's worth thinking about is the timing of sample collection, both for water samples and for ecological samples. When I started getting into this literature for the effects in fish and macroinvertebrates, they were seeing effects on the organisms at something like 40 or 50 or 60 milligrams per liter chloride, but they were collecting both their ecological and their water samples in April and May in the spring. And so weren't really getting at what was happening in the winter time. And so thinking about seasonal differences and how that relates to when you might be out collecting samples, again, for water chemistry or for ecology, is an important thing to consider. This is the Stormwater seminar series, so I thought I would talk a little bit about some work my students and I and colleagues and I have done looking at how chloride interacts with stormwater basins. So looking here at a watershed that's northwest of Baltimore City, there's an interstate that runs through the east side of the watershed, and we're looking at a couple of stormwater basins out in the southwest corner of the watershed toward the headwaters of this stream. This is a watershed that developed substantially in the 90s with an increase in the number of stormwater basins from 20 just after 1980 up to approaching 200 in 2005, 2006, and I think it's above 200 now. So we're going to zoom in on this red box in the lower left. And looking at these stormwater basins, here are two condo developments outlined in red on the left, green on the right, and then also some nearby roads, all of which feed into two stormwater basins. The P6 is the west one, and what we've labeled P5 here in green is the right one, and that receives more salts because it receives more water from the secondary road as well as the condo development. And so we're going to look at what groundwater looks like down gradient of those stormwater basins. So the red and the green arrows indicate where water is coming in from those stormwater basins, both as surface water and as groundwater. And looking at June 2009, you can see little patches of 500 milligrams per liter chloride in the groundwater, and then lower than that around there. And then moving through a substantially snowy and salty winter, you can see concentrations in these plume maps of chloride up to 2,000 or more milligrams per liter down gradient of those stormwater basins. And so stormwater, is supposed to often, or stormwater basins are often built to promote infiltration of groundwater. One effect of that is the chloride travels with that infiltrating water. So we're going to look at data over a couple of years at a well that's down gradient of one of those stormwater basins. So this is now concentration on the y-axis versus date over, I guess, about a 2-year period. and concentrations in moles. Sorry, I'm a geochemist, but in gray here you can see in milligrams per liter, so 230 milligrams per liter, and then 3550 up here. And these are sodium and chloride concentrations in a shallow well. And so you can see a large variation in concentration from less than 230 up to several thousand milligrams per liter in the winter, and then back to below 230. So high concentrations, but moving through relatively quickly in the shallow subsurface, about a meter below the surface. Roughly 2.5 meter well located right next to that shallow well saw a different pattern where concentrations were much less variable, but were slowly increasing through time. They were lower in the winter, higher in the summer. And so the big takeaway from this is that groundwater can store substantial amounts of chloride, and then the chloride can be leaked out or enter streams and lakes via base flow over years to even decades. And so we've got a legacy of chloride sitting in groundwater that will continue to affect our lakes and streams for decades. And then going to look real quickly at a couple of stream sites just down gradient of these plumes, and show how the groundwater entering from these plumes is affecting the stream concentrations. So here's concentration again on the y-axis, and then time over about a 2-year period on the x-axis. And you can see that both chloride and sodium concentrations increase in the winter, as you might expect, both in year 1 and in year 2, and then decrease in the summer. And this is upstream of those stormwater basins. And then here's the site downstream, and you can see that concentrations are about 2 times higher for sodium and chloride at the peak as they are in the site upstream of the groundwater basins. And the export, because groundwater, or because stream flow is higher, export of chloride is about 3 times higher down gradient of these stormwater basins. So no, that's a lot of information. So sort of summarize some of the knowledge and research gaps as I see them for thinking about chloride and freshwater systems. So one of the big questions that remains is how much are private entities, shopping malls, individual vendors, HOAs, how much are they applying, and how can we encourage and implement best practices? And I think some of the panelists have great information on that. There's some evidence that these private entities apply at higher rates than municipalities, than government organizations, in part because they're worried about lawsuits. One estimate from Toronto thought that 14 to 40% of what was applied in their watersheds was coming from private entities, and in dense urban areas like downtown Toronto, it would have been much closer to that 40% mark. A big question is, what's the residence time of chloride in watersheds? And of course, that will vary based on climate, size of the watershed, et cetera. Stating that another way, if we start reducing application rates, but maintain the same level of service, how long would it take to start seeing reductions in stream concentrations? And then I think there's a lot more for the ecologists and biologists, ecotoxicologists to figure out about how freshwater communities respond and change in response to stress from chloride, and perhaps chloride from different sources like sodium chloride versus magnesium chloride. And of course, this will vary across ecoregion, vary, say, between the Midwest and the Mid-Atlantic. And one thing sort of more in detail on this topic is, I think it's worth thinking about key thresholds. Like maybe with these urban systems with really high chloride, there's sort of a lost cause, and maybe a place to really focus is on, low development watersheds and preventing those, or trying to help those not get above a threshold where a lot of effects start to happen. And then how can we use existing data to extrapolate to non-monitored or less frequently monitored streams and lakes? So as an example, in our study on the East Coast, we looked at how frequently the EPA chronic criterion for chloride was exceeded as a function of impervious surface cover. We found that for the mid-Atlantic and New England, all watersheds with greater than 9% impervious cover frequently exceeded the EPA chronic criterion. And so it got, reasonably strong correlations, 0.66 and 0.7. Median chloride concentrations correlated even better to the exceedances. And one nice thing about chloride is, since a lot of it is in groundwater, is you can get a good sense for median concentrations by going out on a nice sunny day in May or June. And that chloride is likely to be about the average or median concentration. And then this sort of data is also compiled by Hilary Dugan and colleagues for lakes. So how can we begin to address the issue? For reference, a teaspoon of salt can contaminate or go above the EPA criterion for a 5-gallon bucket of water. 50-pound bag can contaminate more than 10,000 gallons of salt. So the only solution is to put down less salt. And there are lots of ways to move toward that while maintaining the same or similar levels of service and access to roads. So for example, the Maryland State Highway Authority has reduced its salt use by 30 to 50% over the last few years by doing things like switching to pre-wetting or pre-treating. So get the salt wet before you put it on the roads. And this picture on the right shows that wet salt does a lot better melting into the ice than dry salt. Putting down liquids or brines can use 45 to 50% less salt. And if you treat the road ahead of time before the frozen precipitation shows up, that takes less salt to keep it clear than if you have to go out and put salt down after ice and snow has adhered to the road. There are different regulatory paths toward this. In Maryland, they've taken a permit-driven process, particularly via MS4 permits. In Maryland, that works reasonably well because we have very few cities or towns. Most things are done at the county level. For example, I live in Baltimore County, which has almost 900,000 people and extends from the Pennsylvania border down to south of Baltimore City. So that is reasonably workable here in Maryland. In Virginia, they have a few sites with strict regulatory requirements, TMDLs, and then they've used those to try to convince nearby watersheds to take voluntary approaches. And somewhat amusingly, both Maryland and Virginia look at the other state and think they're doing it better, in talking to colleagues from both those states. So to summarize, increasing and elevated chloride concentrations have negative effects on freshwater ecosystems and drinking water quality. Over the long term, chloride concentrations are increasing in streams, lakes, and groundwater across the US, particularly, of course, in areas using de-icing salts, and let's say in areas with medium to high impervious surface cover. In the short term, so on the time scale of less than a year, chloride concentrations are often substantially higher in the winter due to de-icing salt use, with variations ideally characterized by high frequency data. For stormwater, the best management practices for managing stormwater can increase chloride concentrations in groundwater and then subsequently in streams and lakes, though perhaps with some shifted timing. More of that chloride might come out in the summer rather than the winter due to stormwater management, but that potentially could affect the organisms more. And then research gaps include determining chloride patterns and effects at the region or ecoregion scale, and figuring out residence time and how long would it take if we reduce rates before we start to see those effects. The good news is that this problem is increasingly on people's radar, and things are hopefully starting to move in the right direction. Some of the work I've been involved in with Virginia, they've been looking a lot to Minnesota for figuring out how to tackle this problem. I'll pass the slides along and have some links for various resources, some of my publications on the topic. So thank you, and I'll take any questions that you might
have. Thank you, Joel. That was very interesting. I have one question I'd like to start with. It's from Randy Niepresh, and it relates to, we know we have a big problem in small streams and lakes. Lakes are kind of the water body sitting there and just collecting chloride. Luckily, they turn over and release the chloride every fall, not necessarily in the spring, but in every fall. Luckily, they are still doing that. And we have big problems in small streams. But Randy Neatfresh has this question. What are the chloride levels and trends in large river systems, rivers that run to the ocean instead of going to lakes or wetlands? Should we be less concerned about the salt concentrations in urban water that discharges to such large rivers?
Yeah, that's a good question. And I think my answer to that would be probably it depends, right? If it's discharging to, say, the Great Lakes, right? Those have a long, and there aren't any huge rivers feeding into the Great Lakes, but those have a long residence time. And so then all that chloride is going to continue to build up probably for centuries. If you're talking about, say, the Ohio River, right, there are generally downstream communities, or even the Mississippi River, there are downstream communities that are pulling their drinking water from those streams. And so certainly the fluctuations in the large rivers will be much smaller than in the small rivers, but there are potentially downstream communities that are being affected by those. But I don't know if there are any easy regulatory ways to deal with that.
Okay. Randy Neatfresh has another question. Does the chloride data show that we are already at a crisis state, or do they show a trend that a crisis state is probably coming in the near future? And the second question is, does this vary by region?
Yeah, I think it very much does vary by region. And there, like New England, there are some sites, feeding drinking water reservoirs that have concentrations in the several hundred milligrams per liter. So I'd love to know what they're doing to treat their water when they're pulling in water that is that salty. Here in the mid-Atlantic, I think it's starting to approach the point where the drinking water entities are really starting to pay attention. Some, like the one where I get my water from, they've been collecting chloride monthly since the early 80s. So at least they have a sense for where the trends are going and how things have changed. I talked to one a little bit south of me who they haven't collected data in 20 years, so they don't even know what their trends are yet. They can go out and see chlorides higher than would be ideal, but they're still trying to assess the trends. The effects do certainly depend on local water chemistry. If you have more carbonate rock, that means you tend to have more calcium and more buffering capacity or alkalinity in the streams. And so the organisms in those streams tend to be better adapted, and both calcium and alkalinity seem to have somewhat protective effects against chloride toxicity. And then the corrosivity for drinking water is also less as well. So it does seem, maybe the Midwest has some conditions that, the same chloride concentration in the Midwest and the Mid-Atlantic is likely to be more of a problem in the Mid-Atlantic because of the background sort of geology and geochemical conditions for streams. But yeah, I think it's definitely, it's like climate change, right? It's one of these big long-term problems. And so the sooner we can start to address it, the less expensive it will be to address it down the road. But there are places around here, homeowners who they've had to put in $20,000 reverse osmosis systems because they live near a road where de-icing salt's used, and their water's corrosive enough that they're replacing their water heater every couple of years. And so that's not a societal crisis yet, but that's certainly problematic for them.
Thank you. So Doug Kimball has this question. How do you interpret the difference in chloride concentration with the depth in your groundwater monitoring data? Based upon your understanding, what accounts for the difference?
Yeah, great question. What we think is driving that is that the shallower well, let me go back to that real quickly. With the shallower well, I think that much of the water feeding into that well is coming from surface water output from the stormwater basin. So it's coming out onto the surface and then infiltrating down. And it's a lot easier to flush out that water because that same area is getting, high storm flow events coming out throughout the year into that, top couple of feet of the aquifer. And so think just the water moves through there really quickly, whereas the deeper well, the one that's sort of going up through time and varying less by season, think that that's probably mostly being driven by the water that's infiltrating from the stormwater basin and then slowly moving out toward the stream on the time scale of months to years, versus the surface water pipe that's coming out and dumping onto the top, and then infiltrating down a few feet, and being flushed through on the time scale of probably weeks to a couple of months.
Okay, here's another one. This might be related to Randy Niepresh's question. It's from Ben Jenke. What do you think are the approaches to address that second knowledge gap, lack of lag time of chlorine, and how long before we see the change in response to modified applications? Is there a role for modeling or analysis of high-res data or tracers? How would you handle that?
Yeah, that's an excellent question. I think all of the above. I definitely think modeling is a good way to do it. I'm blanking on her name. Krista's her first name. There's someone who did her PhD at Syracuse who did a really nice study for central New York, where it did some modeling of stream concentrations tied in groundwater and was looking at residence time of decades for some larger rivers. Certainly, if there are tracers that you can use to date or get a residence time for water, that would be quite useful. And I think there probably are some ways to start backing it out of some of the high frequency data. But I haven't worked on that. I know there's a group in Northern Virginia, including Stanley Grant and others, who are looking at the Occoquan Reservoir set of watersheds, and they're starting to use transit time analysis, which is a tool that's an approach that's being used more and more in the hydrology community to look at basically the distribution of ages of water entering a stream. And it's a mostly modeling approach, but calibrated with stream chemistry, and using that to understand both short-term and long-term drivers of chloride in their watershed. That again, there's a water treatment plant on, so they're trying to understand and then model out to the future, coming decades, what they're going to have to be dealing with as a drinking water authority.
Okay, so more research of all kinds, right?
Yeah, what else is an academic going to say, right?
So Douglas Mensing has this question. I know it's very challenging, but what are the natural, physical, biological, or chemical ways to remove salt from surface water or groundwater?
Reverse osmosis is a good way, but it's really expensive, energetically and otherwise. And I have seen hints of a couple studies where you can come up with a kind of physical way. Basically, you get the salty water to sink into a well and then pump it out, but then that's expensive because you have to have people going out and emptying sumps, and I don't know how scalable something like that is. There are some hints that maybe plants can remove a bit of the sodium, but I'm not particularly convinced that that's a scalable or particularly effective solution, given how high the chloride concentrations are in many of these stormwater basins. So yeah, unfortunately, there aren't all that many cheap or scalable ways. There are certainly ways you can do it, but scaling it up to watersheds and an affordable way to do it is there. I don't know of any. And that Steve Corsi's paper from 2015, I think it's as explicit a statement as I've seen from someone from the USGS, which is the only way to reduce it is put less of it down.
Here's a kind of a specific question from Ron Howard. He is from the city of Winona, Minnesota. Roughly speaking, what does a high frequency monitoring system cost?
So the one my lab has tended to use are Hobo. Onset is the company. So those, I think, went up due to inflation. I think they're up to $825 a piece. And those are dumb sensors in that you have to put them out in the stream and you have to walk out and, basically hold the sensor, hook it up to a device to be able to pull the data off. So that's the cheapest I've seen that's commercially available. And then they go up to thousands of dollars, like the ones the US Geological Survey uses, where they can be wired into data loggers and then telephones back to a server so you can get the data from the comfort of your desk. There are some initiatives I've seen. I think there's one in Oregon or Oregon State where they're trying to use cheap electronics and come up with DIY ways to do it. Like I think they had a little like PVC system you could put out in the stream, and they were getting down in the $50 to $100 range, which could be really interesting. But then you have to have people who know how to get the electronics up and working and troubleshooting them. And so depends on what you're going for. But commercially, $800 plus several $100s for software and a shuttle to pull the data would be the cheapest that I know of.
Yeah, I can speak from experience that troubleshooting is expensive.
Right. Yeah, I've decided my grad students' time, I have enough money to buy them. So my grad students' time would be better spent on understanding the data than trying to troubleshoot everything. And there's still, even with the commercial ones, you still have to troubleshoot. Did you put it in a place that sediment gets dumped on it every big storm? And so you're getting bad data. And yeah, there's still troubleshooting of a different sort.
Here's a question I've been trying to avoid, but it's got a lot of support. So I'll ask it. Our stormwater regulations strongly promote the installation of infiltration stormwater BMPs. How wise or foolish is it to site such infiltration BMPs adjacent to arterial roads and highways that receive high levels of road salt all winter? That might be more of a statement rather than a question, but that's phrased as a question.
Right. It's a matter of trade-offs, right? And there are a lot of negatives about feeding water off a road directly into a stream, erosion and lots of other things. And so, yeah, and the problem isn't the BMP, the stormwater management approach per se, it's the salt. And so it's trying to balance out the negatives on those. Yeah, I think that's my basic approach. Yeah, that's my answer.
All right, okay. So here's another one. Is the data for chloride increasing in groundwater limited to the superficial aquifer? Any ideas if there is an impact on deeper groundwater, or do the confining layers protect that?
I think that's somewhat regional. I think it's mostly, it depends on what you define as shallow, right? I think a lot of it's in the top couple hundred feet. I'm getting to the edges of what I know. There are some nice studies done in the Chicago area where they might have looked at some deeper aquifers, 2010, 12. I could dig them out, or maybe the lead author's name will come to mind. Actually, one of the things, not probably for Minnesota, but for Michigan or parts of Pennsylvania or Maryland, is actually get deep salty water coming up from geologic brines. So more of the time there's salt coming up, and then trying to distinguish between what's coming from the subsurface and then what's coming from road salt. But I would think, sort of how long, given the time spans it takes for groundwater to flow, it's probably not much of a problem for deeper groundwater. It's not likely to be for a while, but that's at the edges of my knowledge.
I guess it depends upon how much pumping of groundwater we.
Exactly. Yeah, exactly. There are a lot of details on that would vary from aquifer to aquifer. Yeah.
So this is the last question. Andy Polzine from Shingle Creek Water Management, Water Management Center says the Minnesota legislature has considered legislation to limit liability for private applicators as a way to approach reductions in application rates for private sites. Are you seeing this approach anywhere else?
The place I've heard of something along those lines is New Hampshire. And so I know they have, a salting academy or training that if an applicator, private applicator has done that, and can show that they have followed the best practices taught in those, then they can get that limited liability coverage. But there are a few conditions along with that. And I guess in New Hampshire, that was somewhat patterned after state liability insurance for ski resorts. They use this sort of approach in terms of, best practices and training, et cetera.
So
And
no
I would
place
guess
else
there might be another state or two that move toward that. Sorry. Go
Yeah,
ahead.
I was wondering. So no place else besides New Hampshire then, huh?
Not that I've heard of. And I know there are other places doing trainings, but like I know in Virginia, the Department of Environmental Quality thought that sounded good, but they are regulatory, not a legislative body, and so they didn't have much control over that. Is something they could pass along and recommend, but thanks,
Yeah.
Andy.
It's similar in Minnesota. We've had difficulty getting that passed for many years. So we will now take a 5-minute break, and Andy Erickson will return with a panel discussion featuring Joel and local experts, Brooke Asleson, Connie Fortin, and Jessica Wilson. So we'll see you in 5 minutes. Thank you for coming.
Welcome back, everyone, to the Minnesota Stormwater Seminar Series. My name is Andy Erickson, and I will be moderating the panel discussion today. And it's my honor to introduce our local experts and ask for their relation to this topic. And they have graciously agreed to serve as panelists this morning. Before I introduce our first panelist, I do want to make a note that Mother Nature wanted to make a statement about our topic today here in Minnesota. And we are all virtual because of the amount of snow that's continuing to accumulate outside our homes here in Minnesota. But again, I will start by introducing our panelists. Our first panelist is Connie Fortin, who is a senior project manager at Bolton and Menk Incorporated, formerly of Fortin Consulting. Connie, from your perspective and experience, how do you relate to this topic today?
Well, Andy, thanks for having me here, and thanks for hosting this topic. I'm really happy for this platform. So my background is I spent about 20 years or so training plow drivers to be more efficient, integrate science into winter operations, to try to drive down the salt use. And I got quite an education in doing that. And basically, they told me where our infrastructure fails in the winter. And now I work for a company that designs infrastructure. And so I've taken it to our civil engineers and our landscape architects and our planners. And I said, we need to design better for winter. And that's my latest passion. So that's what I'm working on.
Thanks, Connie, and thanks for being here today.
Mm-hmm.
Our next panelist is Jessica Wilson, who is the Water Resources Manager for the City of Edina here in Minnesota. So Jessica, from your perspective and experience, how do you relate today to this topic?
I'm also really happy to be here. Thank you. I've traditionally worked with public works and operators, applicators on a municipal side and partner agencies. And as we've ticked off a lot of that low-hanging fruit, we're kind of starting to delve more into that next layer of working with municipal facilities and private property owners. So I do a lot of work in that building knowledge, supporting operators and implementing the best technology and best practices, and then also crafting policies and programs to help people reduce their chloride reliance.
That's fabulous, Jessica. Thank you so much. Our next panelist is Brooke Asleson, who is a former SAFL alum. Thank you, Brooke. And now the Chloride Program Manager or Administrator at the Minnesota Pollution Control Agency. Brooke, from your perspective and experience, how do you relate to today's topic?
Well, thanks, Andy, and glad to be here with all of you today, and always excited to talk about this topic and learn from everybody else. I have been working on chloride at the MPCA for 15 years now. I started doing chloride TMDLs and authored the chloride management plan for the state of Minnesota and have shifted in the last 5 years to creating and now running a statewide chloride reduction program that oversees our smart salting training program that's been in place in a variety of forms since 2006, as well as creating new resources and tools to help all of our permittees and our partners to reduce their chloride use. As we heard from our speaker today, reducing chloride at the source is really our best option for addressing this pollutant. So I have focused and have 100% of my time now dedicated to figuring out ways to help reduce chloride getting into Minnesota's waters.
That's excellent, Brooke. Thank you so much. And thank you for being here as well. I will not ask for Joel's relation because he set the stage. He gave us the keynote that set the topic for our discussion today. I will dive into questions. I will encourage the audience to please continue to put questions into the Q&A window. Please add upvotes to the questions you like so they rise to the top and we get to them. Any questions that we do not answer today, actually, all the questions that are submitted will get shared with not only our speaker, but our local panelists. So they have an opportunity to provide answers and links to additional resources. And all of that information will be shared back with everyone that registers for today's seminar by email when the YouTube recording is available. So continue to post your questions and continue to upvote the ones you like. I'm going to dive in. There's a lot of great questions. I want to dive in with one question though, because I want to get our panelists a chance to describe the biggest challenges we still face today regarding road salt. As Joel mentioned, there's been a number of studies and there's been research here in Minnesota on road salt and the impacts, but what are the biggest challenges we still face today regarding road salt?
Well, I'll just jump in, Andy. You know, I think number one is it's a well-kept secret that we have a problem. It's not on the 6 o'clock news. We have a chloride management plan asking every person in Minnesota to use less salt, but how many people in Minnesota know that, right? So if we don't understand the problem, we can't do anything about it.
I'll add on to Connie's note about when we go talk to people about chloride and try to build some knowledge, they're often surprised to hear that stat, 1 teaspoon in 5 gallons. And how long have we been kind of throwing that alarming stat out there, and people are still surprised. They still have some perceptions about liability that maybe are grounded in truth and not. So I think people are still surprised. But I think also, in addition to that knowledge building, is that technical support or hand-holding really. What should you do about it? I think a lot of people want to do the right thing. They just don't know what that is. So how do you help people, fit the right equipment or advocacy or monitoring or whatever it is so that they can take that next step?
And I think that Jessica and Connie have both highlighted excellent examples. And I will just add to that I think the public expectations are challenging to meet. I think that people have gotten accustomed to getting where they want as fast as they want to, regardless if there is snow or it's summer. And that can be a challenge when the expectations are somewhat unrealistic that are put on our winter maintenance professionals. And there are, though, concerns that no one wants to create unsafe conditions. And so it definitely has put a tremendous amount of pressure and stress on the winter maintenance industry to respond to somewhat unrealistic expectations. And I think that knowledge with, educating the general public as well, that I think we're making great progress on helping educate, the winter maintenance industry. And now we're starting to delve into property managers, maybe elected officials, starting to, work with that group. But I think that general public is still a challenging group to get information from that they will actually, respond to or listen to and take the time to take action on. So behavior change is a lot more challenging to create than just educating people.
If I could jump in real quickly, something anecdotally here exactly on that point was the people I talked to from Virginia Department of Transportation indicated that their practices changed with a lot more salt application after a couple of big winter storm events in 2009, 2010 in the DC, Northern Virginia area. And people's expectations, drove increases in salt use that they weren't necessarily looking to do, but bunch of politicians and both probably local and federal expressed their displeasure, and it changed.
And that can be the struggle, right? Loud voices can be heard. And so maybe education and dissemination of information and really giving people the opportunity to think about that balance. What are the trade-offs? So we need to think about those things. So let's dive into the audience questions. Again, please continue to post questions. I love these questions because I don't have to answer them. That's on the burden of you experts to handle some of these tough questions. So there's the highly voted question at the top right here is by Greg Berg. Why aren't there regulations on the amount of chloride being applied? So we talked about regulations of concentrations and TMDLs and things like that, but there are groups that are claiming they're applying less chloride, but it sure doesn't look like it, right? All of you have seen the roads and the parking lots that look white, not because of the snow, but because of all the salt, right? So does anybody have any comments on that concept? Why aren't there regulations on the amount that's being applied as opposed to just regulating the effluent or the water bodies that receive all the salt?
Well, I can go ahead and jump in on that one as the regulatory agency here in Minnesota. You know, we're required to have laws in place for us to, enforce or have regulations. And so until the, policymakers, those elected officials decide to give us the authority, we as a regulatory agency, like I can't just say, hey, we need to start regulating everyone that applies salt. I can't do that. And so we need to actually get laws in place. And then once those are in place, then we can enforce those. I will say, though, we at the MPCA are taking measures to do our best to not only utilize our existing regulatory framework, but also our additional monitoring and other programs at the agency. And so we have incorporated chloride requirements into our most recent MS4 permit. There's a lot of different ideas in there. And one of them is particularly for those MS4 communities who have a chloride TMDL that has a waste load allocation. They actually are required to track the amount of salt they are using annually and report that in with their MS4 reporting requirements. There's a few other things like annual training of staff who do winter maintenance. And we also have worked chloride into our wastewater regulatory program, where we now have a limit that is assigned to our wastewater facilities that they cannot exceed a certain amount of chloride that's calculated based on, the volume of water they're discharging to the volume of water that they're discharging to ensure that we're not causing or contributing additional chloride impairments. And then we have plans in place to work with those facilities to come up with a plan for how they're going to reduce the amount of chloride coming to their wastewater facilities. So we have, done what we can with our existing regulatory framework to try to get more action on reducing chloride. So I think that, there's definitely opportunities to continue to improve and enhance that. But, we have to kind of work within our existing regulatory framework.
Well, I might just jump in. This isn't exactly regulatory, but it's super interesting. Brooke and I have been in a few discussions now about looking at chloride pollutant trading. So we're tasking the point source to reduce it at huge a cost to our communities. Is it possible to do a non-point point source trade and lower those levels in the sewer shed sooner and cheaper? So stay tuned for that. We're going to bring it up at the Salt Symposium. And I don't know, it's really interesting to me.
I want to chime in as a regulated party under the MPCA and as a regulating body also for properties within the city. I think that regulating how much people apply would be really, really tricky to judge. And it's so, it's going to vary so much based on the storm and the property and the customers that they serve. So I feel like I don't want to go that direction yet. I think there's a lot of other more fruitful paths to take first. Liability legislation being the most obvious, biggest opportunity. And then I think, what materials are used. I think there's a lot of technology advancement we can make in like the materials that we're using for winter maintenance. But to tell someone that they can only use so much, and then they're also facing this pressure on the other side of liability risk, and then they're kind of stuck in the middle of like, well, what do I do here then to protect myself and the environment and all of that? So I think there's a lot of other things we would do before we start to really tell people how much they can put on a property, whether that's municipal or private. But I think that tracking it and that knowing how much you're using, super valuable, right? How do you judge your performance and make things better if you don't know what you're doing? So I think that makes sense. But to kind of come in and say you can only use so much, I think that would just be really tricky to judge and enforce on, and puts people in a tricky spot.
Say, Jessica, let me turn the table on you. How about could you require a low salt design? Could you say we have to design different? We're not going to worry about the maintenance people anymore. We've been worrying about them for decades. Could we say it's required to have a more efficient winter infrastructure?
I think we could ask people to take certain things into consideration, but again, every site's going to be so unique. Can you require, some things might make sense on properties and some things might not. I don't know what those criteria are yet, so it's hard for me to say like, yeah, this makes a lot of sense or this doesn't. But if that were just like the status quo of how we do our work, I think that is definitely a move in the right direction. I think municipal buildings or publicly owned buildings are the most logical place to test that. I imagine some of the sustainability things were similar, where they were tested out in public spaces first and then got a lot of traction and make a lot of sense. And then other people are adopting those things because they make a lot of sense. So I think we're on the right track with that design. As far as requiring it, I feel like it's a little early. We need to kind of proof of concept and business case it for people. And then they'll say, oh yeah, this makes a lot of sense. I want to jump on the train.
Yeah, I agree.
Well, and I think, it brings up a good point. What are the other sides or the ramifications of implementing either a limit on the amount of salt that can be applied in a given year or under certain circumstances? And you'd have to think about how does that actually implemented, but at the same time, regulatory on design side. I think we need to think outside the box, right? Because what we've been doing so far hasn't gotten us there yet. So we need to think of other ways of managing salt and doing it from multiple angles. But maybe if you can comment, just think about the other side, like what would be some of the barriers, or what would be some of the challenges on some of these? Because, we can have great ideas and yeah, it sounds great, but there's always trade-offs. So what do you think about that? Are there other barriers that maybe people are not considering on a total limit for how much is applied and or alternative designs?
Well, I think I'll just jump in that as far as kind of these barriers, I think a lot of it is the training and the education of what is available to do this job differently. And we have found through our Smart Salting training program that many of them are unaware of the impacts that salt is having on the environment. And once they are provided with that knowledge of, wow, I didn't realize the impact my work was having on these waters I'm very passionate about and, recreate on and value, they're willing to make changes, and then providing them, more detailed information for how they can still balance safety with protecting the environment. We see great successes. And so I think that, rather than trying to tell them specifically how to do their jobs and how much salt to apply, we really need to focus on making sure they have all of the available knowledge, training and resources. They need those tools. They need those weather prediction, programs in their plow trucks. They need to have a lot more detailed information so that they can be smarter about how they manage those surfaces. And I think that's really been the crux of kind of the work we've been doing over the years here in Minnesota, collaboratively, not just, MPCA and Fortin, but many of our partners. We're all trying to get as much information, knowledge, and actual tools so that they can be more effective. And so I think that training is, if I had to pick one thing that I think could get us where we need to go, is getting everybody trained. And not just the winter maintenance plow drivers, but we need to make sure that their managers, supervisors, their administrators, those who control the budgets, and our elected officials all need to have a kind of that same level of understanding of the challenges we're faced with. And then when we have that in place and everyone's on the same page, you can make wonderful things happen. So yeah.
When we asked applicators, you know, why are you over applying? A lot of the responses we got were, the customer wants it. It's a consumer demand. And so we thought, okay, well, if we go to the consumer and we, you know, give them, they can build their knowledge on why, what does overuse look like? What are your alternative options here? People are often surprised, and people want to do the right thing, but they don't always understand the issue, or what to do about it. So I think that next peel the onion style thing you can do is to help people do the thing that they already want to do, they just don't know how to do. So I compare this to like my insurance broker. I don't know a lot of things about insurance, but my broker will ask me questions. You know, do you rent your home or own your home? Do you have a car? Who drives your car? Is it just you, or do you have a team driver? They ask the right questions. And then they say, here's what I think would work for you based on your custom situation. I don't have to do any research of my own. I don't have to, you know, read the manual on insurance. I don't know if that is even a thing, right? So I think having a local expert that can give you advice and say, here's what I think would work for you based on what you care about, what your situation is, what I know about you. And I'm going to help you do that thing. I'm going to help you write that small business loan. I'm going to help you apply that grant. I'm going to tell you if your current service provider is trained or not. I'm not going to send you to the MPCA website to figure that out on your own. I would not do that to you. But I will look for you. Or, you know, hey, a contract might work, might be a better solution for you. Or, you know, you're coming in for a permit. I'm going to help you address a drainage problem that's causing those, you know, those meltwater footprints that we're trying to get rid of. So I think there's a little bit more of that, like high touch, hands-on technical support. I'm going to give you some good advice versus right now, I think we have a lot of things that we're building and we're working really hard on all these great resources, but then there's this disconnect in what people know and what action they're taking. And I think it's because we're kind of like, well, it's out there, you know, you figure it out, or I put a Facebook post up there every January. But I think it's going to be a little bit more of like, hey, let me help you with your situation. And I know who you are, you know who I am. And I'm going to check in with you every year and say, how was last winter? What can we do next? I think that's the next level of approaching the private side anyway.
Yeah, that's great.
Well, let me just add in, you guys, training and education is so important, obviously. I love it. But we have just overlooked the engineers and the planners and the architects. And I feel bad about that, but we gotta move on and lay some of this on their table too.
For sure, we gotta again open up the toolbox, right? We need more tools in the toolbox to challenge or to tackle this challenging problem. You know, and actually that segues really well into the next question I want to ask. And this comes in from Sam, and the question is, in your opinions, how serious or how seriously should the water quality world be taking this issue of chloride? So for example, in comparison to phosphorus and suspended sediments, right? I mean, we put a lot of effort and work on phosphorus reductions, on sediment reductions. We're doing a lot of work on chloride reductions, but is it equally the same amount of effort? Should it be more? Should it be less? Where does it rate?
I could just jump in real quickly.
Yeah,
A
please.
slide I didn't show because it's now a little old is Meg Duffy, who's an ecologist at University of Michigan, tweeted several years ago that she thinks chloride is the freshwater issue of the coming decade, similar to, say, phosphorus was in the past.
I think phosphorus and chloride are the top two. Phosphorus rings the phone, right? I can see the algae and there's a harmful algal bloom. So that I think will always be at the top, but certainly chloride, at least from like a water resources management perspective, I'm putting that in the same category of like highest concern pollutants. It's more invisible, as people have said here, when trying to get people to take action, but certainly I think those two, phosphorus and chloride, are at the top of my list locally, at least in the city of Edina.
Well, and I think that the fact that, you know, the MPCA is the first state environmental regulatory agency that has created a chloride reduction program shows that our agency also considers this a top pollutant of concern. We're a small but mighty program. But the fact that we exist, that took work, because that was, it was challenging to kind of elevate the need. And I think that all of the data, all of the great research that's been going on that helps support just how big of an issue this is, because as we've been getting more and more researchers, doing their side of things, we're learning about all of these extra negative consequences. So we knew, back from the early 80s about the toxicity, but all of these other, that's freshwater salinization, these negative impacts to our infrastructure, of course, and we're just learning more and more and becoming smarter. The potential release of phosphorus in our stormwater ponds due to elevated chloride, a lot of negative consequences. Lake mixing, we actually have a lake in Minnesota, Brownie Lake, that is meromictic. Now, we don't know for sure if chloride is completely to blame for that, but there's a lot of chloride in the bottom part of that lake that isn't going anywhere. So I think that all of that has really helped us to become smarter as, scientists and water resource professionals. And I definitely, of course, personally think chloride should be getting all the attention that it has and getting more. And I think just the more that we can do as a community to support that need, that background information to help us elevate chloride. I think the fact that we've got 54 surface waters in Minnesota that are already above 230 milligrams per liter. And if we had Canada's criteria of 120 milligrams per liter, we'd probably have over 100 surface waters that are above the standard. And so just to keep that in perspective, that Minnesota did adopt EPA's standard that was created many years ago at that 230 milligrams per liter, where Michigan just came out with their new standard that they developed that was more site specific and based on more current research and data, and theirs is 150 milligrams per liter. So I do think that we definitely are at the point where action needs to be taken by everyone on all different sectors, not just the winter maintenance professionals. There's a lot more people who have a role to play in helping us address this pollutant. And so I think that, we at the MPCA do think this is a priority of concern and a top priority. It was in actually our strategic plan in the last 5 years. So we've done a lot of work to try to elevate it and connect with other programs so that we can hopefully get more attention on this pollutant.
I would like to say to any community out there, if you don't know the sources of chloride coming into your community and what amount, you need to look at that and you need to pick up the top ones and work on them, because it's your freshwater future. You need to understand it and you need to be launched into action. I personally think we can put everything we do on phosphorus on hold for 20 years, focus on chloride and try to protect this permanent pollutant from eroding the fresh water.
I'll just piggyback on Connie's statement about understanding your sources of chloride. There's been some great work in Minnesota in the last few years to help us, better understand where all the chloride's coming from. And I think that's wonderful. We now know that we've got those kind of top 3 sources, the de-icing salt, fertilizer, and water softening salts. But we're in the process right now of creating a smart salt. We have a smart salting tool and we're updating it. And what we're going to provide is our partners and our permittees the opportunity to select their geographic area, and we will provide an estimate of where the chloride is coming from based on best available information. And so we agree that understanding where the chloride is coming from is really important. And so when I'm working with the wastewater community on how they can address chloride, we're looking at very different sources than when we're hosting one of our smart salting trainings for those winter maintenance. And so I think understanding where the chloride is coming from is definitely step 1 in making sure you're on the right track to addressing it properly.
So Brooke, I'm glad you mentioned the fact that the state of Minnesota has our statewide chloride management plan. And a question actually piggybacks on that. Randy Nieprash also said, he believes it's quite rare for a state to have a chloride program and a full-time staff person focused on salt and chloride. And he's wondering, can you speak to that? Are there other states that are doing something like that or anywhere near the level of effort that we do? Or is it quite unique to Minnesota?
Well, we actually do have a recently formed National Chloride Collaborative that is led by EPA Region 5 and myself. And so we do have a wide range of states, and we've opened it up to states outside of Region 5, because most of the other state agencies that were contacting me, Maine and Maryland and Virginia. So I was saying, well, hey, we need to expand this. It's not just a EPA Region 5 issues, because the other states that seem most interested in learning what we're doing in Minnesota are outside of that region. And so we have formed a team that now is meeting about 2 times a year, sharing ideas, resources, learning from each other, and actually partnering up to kind of be a little more collaborative. And if we don't need to reinvent things, we can share, we'll get, where we need to be faster. As far as I know, Minnesota is the only state that has a specific chloride reduction program and a staff person that is 100% dedicated to working on chloride. I know that other states are interested. I think Wisconsin DNR might be trying to move in that direction of getting an actual staff person that has a little more capacity to focus their attention on this issue. But it usually falls maybe within their TMDL or watershed programs are typically where you'll find the staff people who are digging into this, because, they got to do a chloride TMDL because there's a water quality impairment. And then, you've got states like New Hampshire who did, create a training program and get that legislation passed. And so they're doing some of that, but they are not taking all of that on as the state agency. And so I think we are unique. I think definitely there's a lot of great work going on in many other states where none of us are taking the exact same approach. And so that's where having that national kind of group for us to share ideas and resources is, I think, going to be really helpful for everybody.
And that, I didn't mean that question to be just for Brooke. Is there anybody else that wants to add other things that they've heard from other places outside of Minnesota that maybe our attendants might benefit from knowing about? I know I've also been contacted by folks from Wisconsin and Michigan on this road salt and chloride issue. So like Brooke said, Region 5, there's a number of states working on it, and as well as New England. Yeah,
in the Mid-Atlantic, so as I sort of mentioned, Maryland's handling it mostly through MS4 permits, which again, there are 20 counties in the state. It's easier here than in many states with lots of municipalities. And the details are each municipality or MS4 permittee has to develop a salt management plan, and then they have to monitor at least one site if they're a small municipality or permittee, and 2 sites, a first and a third order stream, with conductivity monitors if they're a larger permittee. And then state legislature passed a salt reduction plan for state highway authority only, over a decade ago. But then there's everyone else who applies the salt who isn't covered under that. And then Virginia and Maryland doesn't have chloride as a regulated element. So these are all, that's part of why they're doing that. Virginia does. And so they do have a TMDL in a watershed, one with a water treatment plant, drinking water treatment plant reservoir in it in Northern Virginia. But then they're taking this voluntary approach with sort of the hovering hammer saying, we'd like you to do this all voluntarily in Northern Virginia. We have a regulated TMDL in this one watershed, and we'd prefer not to use that. So let's see if we can do education. And they did a really good job, I think, talking to people in Minnesota about figuring out all the different prongs of ways to make progress on it.
That's great. So I'm gonna pivot a little bit, actually, and it fits in with something Joel just mentioned. And the question is, many of our buildings and properties will have buckets of salt just sitting by the front door, right? And either the employees or someone else as part of that property owner will add salt, probably likely in response to customers saying, hey, there's ice here, or they walked in from the parking lot and they found that there was ice, so they want to put more salt down. But that's the question, is how big of an issue is that? And do we need, you mentioned training, right? And certification, but are we reaching private business owners? Are we reaching people that are not professional salt applicators, but more on their own? And I want to expand that to, largely beyond businesses, but just in general. Think about the small business applicators, things like that. The people that have a landscaping company in the summer and a plowing company in the winter. How much of that is affecting this challenge that we have, or how much of a part of the problem is that? And what can we do better, maybe looking forward, or what are we doing now and what can we do better to maybe tackle that more specifically?
I will go ahead and get us kicked off. I just was co-teaching a smart salting training for property management yesterday. And we actually have several slides, several areas of that training where we talk about the salt bucket out in front at the entryway. And so I will just add that we have tried to modify our training and try to address a variety of audiences. And so in the last probably 5 years, we added this new smart salting for property management. And that was as a result of one of our private contractors who went to training. They wanted to implement the practices they learned at training, but they got pushback from their customer or the property owner or manager. And so we found some funds and we said, let's create a shorter training that meets their needs better, because they don't need to know how to calibrate the equipment and all the details that goes into using liquid de-icers, but they do care about the damage of infrastructure and the cost associated with repairing the damages that the salt is causing. And so we tried to tailor the class to better fit kind of what they cared about, knowing that the environment may not be the top concern for them. And so we definitely have tried to engage with that audience and expand, who can, have that opportunity to receive training. And then there are some great resources on the MPCA website. We have MWMO, the Mississippi Watershed Management Organization, created some wonderful short videos that was geared for those who just do those entryways, who maybe won't come to training, but are still applying salt. And so there's a lot of, I think, some tools out there that does help engage with that audience. As far as the overall contribution it's making, I think every teaspoon of salt matters. And so while it may not be, having a huge impact overall, I think, if one person can reduce their salt use a little bit, if all of us could do that in different ways, I think it all adds up and it is important. And so I think it's important to find ways that each individual within an organization can help influence some positive change around chloride use. And somebody who's out there, with the bucket, and in training yesterday, we said, well, what else do you have out in that entryway besides a bucket of salt? Do you have a shovel? Do you have a broom and a bucket? Do you have other tools besides just salt? Because if that's the only tool that you're giving them, of course, that's the only thing they're going to use. And so I will let the other panelists jump in on that, but that's just my perspective on that one.
Yeah, and the way I describe what Brooke was kind of saying is, if you can activate these people in the community and they're putting on their chloride eyes to say like, wow, that is too much. Now I know that is overuse. Then you're kind of changing just what people expect to see when they go visit their grocery store or whatever. As far as like opportunities go, I think it's appropriate to keep the pressure on public agencies. I think we've seen a lot of strides, but I think there's still more room to grow. So I think that's appropriate to keep the pressure on public agencies. But I think we also need to just start getting more into those private properties. And the commercial and industrial are the next place to go. Residential, I think, is a small piece of that. And like Brooke also kind of said, the bucket in the entryway is probably a small contribution. I think it's more important just to kind of change the way people perceive the liability reducing, does extra rock salt, visible rock salt, reduce your liability? Not necessarily. But I think, commercial industrial is the next big animal. How do you, what program can capture all of those? Can we take a sliver of them and just kind of start to make inroads there? That's what we're trying to do with a low salt, no salt Minnesota program, is say, okay, we're going to reach out to the people that live here or worship in this space and care deeply about how it's maintained and managed. And they're going to make it so that their applicators or who they're hiring or how their building is being managed will shift. The big box stores or the big grocery stores where people, the owner is different than the manager, is different than the outdoor maintenance provider. Those are tricky, but I think, that's the direction that it needs to go, is that commercial industrial space.
I just want to jump in. Of course, this is a topic we all love. So thanks for the question, by the way. I would just say hats off to the city of Minneapolis. Maybe they can put the link in the chat. They have a stormwater credit program, and they're the first city in our state that has chloride reduction for commercial entities to get a stormwater credit. And they have the salt bucket thing in their language. So maybe, I think I saw them in the audience, they could share that. And then all the other cities across the US or wherever you're from, maybe copy them.
Other thoughts or comments on that topic? I'm going to shift a little bit, but it fits right into exactly what we're just saying, because and the question, broadly is, what happens to sodium chloride after we remove it from the water? And so, for example, in this case, reverse osmosis. But I want to expand that question to bigger. What are we doing, or what more could we do to reclaim salt when it's already in the system, but before it gets into our water bodies? For example, street sweeping on parking lots and other paved surfaces where there's excess salt, picking that salt back up before it gets washed off and into the lake, or even pumping salty water out of stormwater ponds. Is that something we could be doing? And is anybody doing that? And how might we handle that salty water? And again, getting back to the original question, what can we do with it? So A, what kind of things are we doing to reclaim salt that's excess before it gets into our water bodies? And B, what can we do with it once we've claimed it? Is that a waste product? Is it something that can be reused? What do we know about that?
I think there's a lot of crossover here on phosphorus and chloride. If you can grab it in its particulate form, it is cheap to do and relatively straightforward. We already have the tools to do that, right? You can go sweep it up. And then grab leaves and twigs and all these other things at the same time. So you kind of get your two birds with one stone with that. As far as what to do when it's already dissolved in the water, I think there's a lot of, can you pump it out and concentrate it enough and then, put it in that sanitary, waste stream? I don't think you can in Minnesota right now, but maybe by the time, we all retire, there'll be some more doors open for that. I don't know. I don't think we have.
Brine be reapplied, maybe?
Yeah, that's a good question. And I wonder if Brooke or Connie or anyone else has some sense of the research around that. I think people have asked that question.
Yeah, that definitely. Oh, Connie, go ahead.
Well, I'll just say, I think it's generally so dilute that the volume of the water makes it impractical unless you're at the salt storage facility. We see some success reclaiming the waste, the spill that's just in front of the building. And their brine making is right there. That is something that we are seeing a slow movement towards.
Yeah, and I would just say on that larger kind of concept of the waste is that, if say we were to implement reverse osmosis at a wastewater treatment facility, that would be cost prohibitive. So I don't think that that's really a direction any of them are going to go, because the cost of that would be too expensive to pass on to their consumers. But it would still be left over with this highly concentrated brine, and it's going to have a lot of other things in it besides just chloride. Reverse osmosis isn't just removing chloride, it's removing a lot of other pollutants as well. And so then you have this, well, what else is in there? And then where do you dispose of it? Do we put it in a closed landfill, or, it's just going to make its way likely back into the environment. So that's where we've really focused on, reducing it at the source, because it is logistically challenging for a lot of different reasons. And perhaps there could be some reuse if we can find a way to, remove just say the chloride and not a bunch of other things. I know there is some research going on in kind of using battery technology to actually separate out those chloride ions. And if that could be implemented at a larger scale, perhaps we could reuse some of that water for brine. As Connie mentioned, it's going to be probably dilute, so we'll still have to add a little bit salt, but maybe we're adding a little less salt. And so that could kind of help start recycling that same salt every year. We just kind of pull it back out and then put it back down on our roads. I don't know that we've got anything that's kind of near that solution. I know that there is, though, some research going on other ways besides just reverse osmosis to try to separate out those chloride. I know some technology that was being looked at in Minnesota to remove nitrate from agricultural areas, and they found that they were also removing chloride. So there could potentially be some more electrolysis kind of related technologies that were be able to maybe achieve some of those results, but right now those are still pretty small scale and have not been implemented up to that larger scale, and certainly not like a lake or a stream scale, because that gets even more difficult when you've got very tiny organisms that live in there that need to stay living in those lakes and streams and don't want to be put through some treatment process and probably wouldn't survive it as you try to dump them back out. So I think that, maybe in the future there's some opportunity for that, but right now I think we really need to cut way back on the amount of salt that we use and find some good alternative options and maybe do some design better so that we don't have to use as much in the first place.
Yeah, a whole suite of things. And I think source control, as you've heard everybody say, is kind of that number one thing. Some other ideas I've heard is, can you capture that really salty first flush and somehow concentrate or evaporate off the water and then like kind of reclaim it that way? But I think Joel mentioned earlier in his talk that that's really expensive from an energy standpoint. And can you, in a carbon, what's the trade-off that you're making then by trying to heat or evaporate off all that water to get it? So it's a wicked problem. There isn't really like a silver bullet, but the leading strategy, as you've heard several times today, is it's multi-pronged and really source control.
I think that's very well said, very well said. And maybe that transitions us into the next question. There's actually a few questions related to this. Other things. So things like permeable pavements as an alternative to conventional pavements. And there's benefits and consequences there. But then also road salt alternatives. There was questions about, can there be a ban on sodium chloride as our anti-icing, de-icing chemical? Can we look at other things? And before I let the panelists jump in on some of these other things and other things we've considered, I want to extend on Brooke's comment about research. We've been doing a lot of research, and I want to highlight MnDOT. MnDOT has not only funded, but also conducted a lot of research related to winter maintenance, salt, and how to manage our roadways. And they are in a very difficult position because they manage so much of our road surfaces in Minnesota that need to be safe for transportation. Right. And they've done a lot of work on that. And if anybody's interested in some of the research or things that MnDOT does, they spend a lot of money on their plow trucks. Right. Brooke also mentioned earlier about the sensor technology and the information systems that are on these plow trucks. It's amazing how much technology are on those MnDOT plow trucks and other plow trucks in municipalities and in the counties as well. But MnDOT has put a lot of effort into developing the technology and the information to make good decisions about how to apply and when to apply salt and what rates to apply it. I just want to mention that because that is there. But let's talk about other things. What are some of the other solutions? Pervious pavement, as I mentioned, permeable pavements, other road salt chemicals. What do we know? What can we do? And where is that going?
I suppose I should jump in here, huh? I guess I'm going to tackle the pavements first because I've been working with our designers. And here's what I say is people are afraid of alternative pavements. They're more expensive. They're just unknown from a user perspective to a designer perspective to everything. And so what I like to say to our designers is, if you can solve the performance in an easier way by using the sun or outsmarting the wind or improving your drainage and so on, do it. But you get into a jam with your winter design and you're not getting the performance, that is the perfect place for an alternative pavement, right? Heated, porous, flexible, non-stick coating, something. So don't be afraid to use it, but use the easier things first if they can work for you. Just Mother Nature's basic tools. But when you can't, then open up that toolbox.
Yeah, that's perfect. We just actually in our training yesterday a little bit about heated surfaces and conductive asphalt. We had a little discussion around that yesterday with our training participants, because there are a lot of new technologies coming out there. And so that conductive asphalt was very interesting, because that's not quite on that same scale of cost as heated surfaces or porous pavements. And so maybe there are some smaller areas where we could focus to try to just enhance what's already there and utilize the sun and what we already have to work with. And I agree completely with Connie that if we could just switch the side of the building that our entrances are on, so that the sun was helping do the job, we would make a huge difference. I have a driveway and I look over at my neighbor's driveway and they're always just clear and ice free because they've got the sun beating down on there, and I have the shade of my garage on my driveway all winter long. And so I think definitely some of those considerations. And I think when we think about the cost of permeable pavers, I think that we also need to think about the cost, the true cost of using salt, of continuing to use these products. They are not only damaging to our environment, but they are damaging to the infrastructure. And so in our training, we have a report from a few years ago, actually 2014, so more than a few years ago, that looked at the overall cost to apply salt. And we say that about $3,500 per ton of salt used is the amount you're going to need to repair those damages. That's what it actually costs to apply 1 ton of salt. It doesn't cost just what you paid for the product. There's a lot more costs that go into that. And so if we start looking, and then if you add in, what will be the cost if we actually have to start implementing some of these more drastic measures to remove chloride from our environment? Let's look at the cost of reverse osmosis at a drinking water facility. The cost for a city to drill a new well and build a whole new plant that can remove chloride is going to be really expensive. And so if we start looking at the cost in a bigger holistic view, I think porous pavement becomes more cost reasonable. I don't think it's, but it's hard for people to think about those longer term costs because we're on like a 2-year budget cycle. And so it can be difficult. But I think that's just something I'd like everyone to think about is think about the true cost of applying salt when you're thinking about how expensive it might be to implement something like porous pavement. On the alternatives, I will just share some of the knowledge that I have. I have had the opportunity to be on the technical advisory panel for several of MnDOT's research projects. So I'm very fortunate to be included and be invited to share the MPCA's perspective on a lot of these research projects. And I think the one that had the most promise was potassium acetate. That one is an effective de-icer. So first, the product has to actually be effective at melting snow and ice. And that has shown to be effective. It's less corrosive than our chloride containing de-icers. And the cost has come down a little bit over the years so that it is a little more cost effective for winter maintenance organizations to consider. And so they did a really great research project to try to better understand that. Turns out the potassium is highly toxic to a lot of different species that are important. And also that acetate, as it breaks down, it uses up the available oxygen in our waterways. And so from all of my experience and knowledge, there is not an alternative that is safer or better than chloride containing de-icer at this point. And so there isn't some, magical solution out there that, oh, we can just use this chemical instead. It's all of the different products have a negative impact on the environment. And thank you to MnDOT's research, we're digging in a little further, because I think up until some of this more recent research, it was just like, well, they all have negative environmental consequences. But we didn't say, well, what specifically are those negative consequences, and are they better or worse than chloride? And so getting in and trying to better understand the very specific ways that these alternatives are impacting the environment and the aquatic life living there, I think is really important, because we do need to start making some decisions like, well, maybe one is better than the other. Maybe it is better, just these consequences are more manageable. Or maybe in certain situations, certain areas, maybe using an acetate when you're not near a water body, and it can break down in that 24 to 48 hour period before it gets to waters. So I think for the research community to help keep digging down to really get to those fine details, so that hopefully we can start having more informed, decisions on, if there are some good alternative solutions.
There was this kind of thinking about like materials and innovation, and I think one potential outcome of that is we use less product. Another potential outcome of better technology and better material is an improvement in your service level, right? All right, we're going to get out there more. We're going to do curb to curb. I think Joel had this great graphic where you saw in like the 70s, there was a kind of a plateau of salt and then it shot up again. Why do you think that is? I think that might be a reaction to, service level. Oh, well, now we can get out there faster, or we can do more. We can, it's not necessarily that there's more surfaces, but that the service driven by behavior or whatever, or pride in doing the work, whatever that is. So I think as we get better and better at doing winter maintenance, sometimes that means we're using less. Sometimes it means that the service is improving. I don't know. You guys can wordsmith later if that's the right word to use there. Increasing the service level. So I think I just want to get that in there too before we end our time here. Is I thought Joel's graphic there. I mean, if you have any other insight, Joel, on why that is, but to me that was, it's not always going to be a reduction in chloride. Maybe. How do we kind of manage that? I don't know. I think that's a interesting kind of juxtaposition of the innovation.
Yeah, and I would love to know if anyone else has insight. As best I have been able to reconstruct, there was a highway bill passed in like 91 or 92, which is about when that jump occurred. And previous to that, I think there was a bunch of funding looking into sodium chloride alternatives because there are a bunch of papers published, 89 to 92, something like that. And the result of that seemed to be that big jump in sodium chloride. So that's a really great point on your part. And if anyone uncovers more of that history, that's the best I've been able to grasp at straws at, but I don't know.
Well, we are quickly running out of time and also quickly amassing more and more questions. So I'll remind everybody that we are going to take all the questions, both ones we've already asked and ones we didn't get to. We're going to share those with the speaker and all the panelists, and they will have an opportunity to provide some more answers, provide some resources, links to things. We have a number of links that have been shared in the chat, which are fabulous. I am going to move us into our closing key question. And the question I'm going to ask for our panelists is, what are our key takeaways from today? What do you want to make sure that the audience hears? And I'm going to maybe add just a little bit to it. So I want you to share your key takeaways, but also maybe give our audience something they can do individually. There were a few questions in here about, well, what can I do about, the local businesses that are in my communities? What can I do about my neighbors? What can I do about places that I interact with to maybe help in the education process? And even that's just asking questions and make it not confrontational, but educational. So what are your key takeaways? And maybe if you have just a tidbit about what people can do individually in their communities and their respective spheres that can make a little bit of an impact in the positive direction to road salt. And we're going to go in the same order that we introduced everybody. So Connie, you are up first. Lead the way.
Okay, thanks, Andy. Well, here's what my pep talk is don't wait for somebody to tell you how to reduce chloride. Invent something. It's a new pollutant. There's a million different things we haven't thought about. Joel has told us it is a serious and irreversible problem. So just go invent something, do something, take action. Don't sit around and wait for somebody else to lead. We can't wait. And if you do want 22 new ideas, come to the SALT Symposium on August 1st and 2nd, because guess what? We have Andy speaking, Brooke speaking, Jessica speaking, and 18 other people. So hope to see you then. And thanks for having me.
I love it, Connie. That was excellent. Thank you. Jessica, you're up.
Well, first, if anyone wants to do a happy hour later and talk more about chloride, I'm all for it. I feel like I have a lot still to say. Chloride is wicked, but I feel like it is a priority pollutant, and we should be really focusing on it. I think my kind of what should you do at a local like LGU level is, I think you got to really engage with people. So this whole like back, we're going to stand back and educate people and we're going to be throwing messages out into the ether. I don't think that's the right approach. I think it's reaching out and connecting with people. And then people often know what the next right thing is to do. They just don't know how to do it. And I think you can be that connection point for them. So I think it's a lot more high touch and, one-on-one, but I think that's how you actually move the needle. So, and then my last note is like, I'm hopeful. There's a lot of angles and a lot of threads that people are following. So I feel really hopeful that there's a lot of progress to be made.
That's excellent. All right, Brooke, what would you give to our audience today?
Well, I would just say that I think we all have an opportunity to have a positive influence on reducing salt use in some way, shape, or form, whether it's on your own personal property, whether it is getting yourself more educated on this topic so that you can have conversations with your family and friends and neighbors to help get them educated. Someone's going to probably be a lot more likely to change their behavior if someone close to them shares really important information and facts and helps them rather than them hearing it from a Facebook post MPCA did or, the city of Edina. We're still trying to help get out there, but I would say get yourself educated and then where within your organization, could you make a difference? Because I think we all have some type of influence. It may not be on the winter maintenance. Maybe it's on water softening or fertilizer. Maybe you have some connections or interactions in your professional work where, you could, be a leader and really create some positive change. And I will just throw out there 2 last resources that will hopefully get in the chat for all of you. We do have a statewide chloride resources page where it's going to be, technical reports and guidance, as well as assistance that the MPCA offers, as well as wonderful materials that our local partners have created, other programs that have been created. We didn't mention the Low Salt, No Salt Minnesota program that Jessica has been very involved with in creating. So we get information from our partners, our communities, and we share it on our website so that everybody can hopefully find it and see if that might work for your organization. Maybe what somebody else is doing, you could, maybe implement for your potential, employer. So I would encourage you to check that out. We also have a smart salting for local leaders workshop coming up on March 9th. This is a 2-hour online workshop that is free to participants and is a really great opportunity for that really high level understanding of the issues and what you can do from more of a policy perspective and an educational perspective. And so if anyone in the audience is interested in joining us, I encourage you to go to our website and register and join for that workshop for community leaders. So of course, there's a bunch of other smart salting trainings as well. So if you do want to get yourself more educated, we just had our smart salting for property managers yesterday. And we don't have one on the calendar, but if this audience feels like they want to have one, I'll get one added. So we'll find a date with our instructors and we will host one, because I think that's where it all starts. If we can all get ourselves educated, then we know better how we can influence our friends, our neighbors, and our communities as a whole. So thanks for having me. It's been a great discussion. I think, as well as Connie and Jessica, we could probably talk about this, for hours. So look forward to maybe seeing you guys at a smart salting training or the Salt Symposium coming up later in August.
Thank you, Brooke. Joel, you get the last word. You started us off. What would you like to share with our audience?
First, my brother who lives in Egan watched this, joined, and then texted me to say I should share that after I told him about salting guidelines and per square foot, he has changed his salting practice. So there's one person putting down less salt. And thanks for the opportunity. This was fantastic to hear all the really cool work that you're doing in Minnesota, working on this issue. And it's been a real privilege to be involved. So thanks so much. And just the whole seminar setup and panel is, I haven't experienced this before, and it's terrific. It's really great.
Well, thank you, Joel. Thank you so much. And I want to say, we had over 270 people at one point in this seminar. If you calculate all 6 degrees of separation for all of those individuals doing one little thing, we can have a pretty mighty impact on salts, not only in Minnesota, not only in the Midwest, nationwide, and arguably globally, potentially. And I do think, we highlighted this because chloride is an issue that we need to deal with. And it has immense environmental ramifications, and we can't go back. We need to go forward and do what we can to improve what we have. So with that, I'm going to close our seminar. I want to thank our panelists. Thank you so much for being here, Connie, Jessica, and Brooke. Thank you, Joel, for being our keynote and setting the stage for the discussion. But I also want to thank the audience for being here and joining us today, providing these excellent questions that we will share with our speakers and our panelists, and for signing up, tuning in, and for doing what you can in your neighborhoods and in your spheres to handle this salt problem. So I encourage you to check in for our future seminars. We're going to talk about a lot of different things, all related to stormwater. We have the Spring of Media coming up. We're going to talk about media and how we can better design to remove more pollutants. Not really going to help us with the salt issue yet, but it will help us with some of our other problems in stormwater management. So I encourage you to tune in for that. Tune in on our websites, check the links for all the resources that we've seen here, and check our YouTube channel if you want to see past seminars that we've had on a variety of different issues related to stormwater, green infrastructure, and urban runoff management. So with that, I will thank you for joining us today. Please tune in for a future one, and I hope you have a great rest of the day. Stay safe, everyone.